This is Anil Kumar, Chemistry faculty. In this video, I would like to explain the importance of topics of atomic structure. So, which is very important chapter for EAMCET, JEE Mains and Advanced. So, first we will discuss concept session, that is main subtopics of atomic structure. Here these are main subtopics of atomic structure. First subtopic is about subatomic particles. In this, we will discuss about electrons, protons and neutrons. E is electron, P is proton, N is neutron. Next, Rutherford's nuclear model of atom, which is also known as solar model or planetary model. Next, wave nature of electromagnetic radiation, that is about EMR, characteristic properties of electromagnetic waves. Next, Planck's quantum theory or Planck's equation. Next, Bohr's model for hydrogen atom. So in this we will discuss about spectrum. Spectrum means here hydrogen spectrum and hydrogen like. We will discuss both. Next, de Broglie's wave equation. That means concept of matter waves. We will discuss wavelength of matter waves in this subtopic. Next, Heisenberg uncertainty principle. So here we can calculate uncertainty in position, uncertainty in momentum. Next, quantum numbers. In quantum numbers we have 4. Principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Next, last 3 are principles to write electronic configuration of all the elements. So these are the subtopics of atomic structure. We will discuss one by one. So first subtopic is about electrons. So electrons were discovered by J.J. Thomson. J.J. Thomson has calculated E by M value of cathode rays or electrons by using cathode ray tube experiment or discharge tube experiment. Cathode ray tube or discharge tube experiment. Next, R.A. Millikan has calculated charge of electron by using oil drop experiment. So in a E by M value of electron, or it is given 1.76 into 10 power 11 coulombs per kg, and the charge of electron according to Millikan 1.602 into 10 power minus 19 coulombs. So from this we can calculate mass of electron, which is E by M. So here E is 1.602 into 10 power minus 19 coulombs and E by M value 1.76 into 10 power 11 coulombs per kg. From this we will get 9.1 into 10 power minus 31 kg. This is absolute mass of electron. Next, E by M value of cathode rays or electrons. independent of nature of electrode and nature of gas. Remember this point, very very important. E by m value of electron is always constant. That is independent of nature of gas and nature of electrode used in discharge tube experiment. E by m value constant for electron. Next, designation of electron E minus 1 0. So electron is indicated like this. So here minus 1 is relative charge and 0 is relative mass. Simply mass of electron is negligible, almost 0, 0.00054 AMU, negligible mass. Minus 1 is relative charge. Next, Millikan gave one relation for calculating charge of electron. Here Q equal to Ne. So this was the relation given by R.A. Millikan in oil drop experiment. Here Q is total amount of charge on oil drop. So we'll write here Q is charge on oil drop. N is number of electrons. E is electronic charge. So these are important points about electrons. Next we will discuss about protons. Protons are indicated with P plus 1 and 1. Here plus 1 is relative charge and 1 is relative mass. P plus 1 and 1. Electronic charge relative charge is minus 1. Proton relative charge is plus 1. Next, mass of proton. Here I will write mass of electron 9.1 into 10 power minus 31 kg. Mass of proton will be 1.672 into 10 power minus 27 kg. Or mass of electron in AMU is 0.00054 AMU. Mass of proton in AMU is 1.00727 AMU. Relation between these two, mass of electron is 1 by 1837 to that of mass of proton. Remember this relation, very very important. Next, we know charge of electron charge of electron 1.602 into 10 power minus 19 coulombs with a negative charge. Well, charge of proton is plus 1.602 into 10 power minus 19 coulombs. And absolute charge of electron is minus 1.602 into 10 power minus 19 coulombs. Absolute charge of proton is plus 1.602 into 10 power minus 19 coulombs. Relative charge of electron is minus 1. Relative charge of proton is plus 1. Magnitude will be same. but sign will be different. Next, in electrostatic units, charge of electron is minus 4.8 into 10 power minus 10 ESU, electrostatic units. Next here, plus 4.8 into 10 power minus 10 ESU. So Coulomb's SI system and ESU CGS system. SI unit and ESU CGS unit. Electrons are negatively charged particles while protons are positively charged particles. So these are important points regarding protons. Next one, about neutrons. Neutrons are indicated with N, 0, 1. So 0 is relative charge, or you can take it as absolute charge. 1 is relative mass. So clearly we can say mass of proton approximately equal to mass of neutron. Approximately. Next, neutrons were discovered by James Chadwick by bombarding lighter nuclei like beryllium or boron with fast moving alpha particles. Alpha particle is helium nucleus, He24 2+. This is alpha particle. Here there is bombardment between lighter nuclei like beryllium or boron and alpha particle. Relativity equation. We take beryllium 4, 9 plus alpha particle He24. It will give 4 plus 2, 6. That means carbon. 9 plus 4, 13. Here write 12 plus N, 0, 1. Neutrons will be emitted in this process. Similarly, we can write boron 5, 11 plus helium 24 gives 5 plus 2, 7. 7 means we will get nitrogen 7. 11 plus 4, 15. Write 14 here. And 1 neutron will be emitted. In these two reactions, neutrons will be emitted. Neutrons means here, remember, neutral particles. Neutral. Next. Here mass of electron, 9.1 into 10 power minus 31 kg. Mass of proton, 1.672 into 10 power minus 27 kg. And mass of neutron, 1.675 into 10 power minus 27 kg. So mass of proton is approximately equal to that of mass of neutron. But here relation is very, very important. Mass of electron is 1 by 1837 to that of mass of proton, and mass of electron is 1 by 1840 to that of mass of neutron. Remember these two, which are important for calculations. Next, in AMUs, already I have given this value 0.00054 AMU, mass of electron. Mass of proton 1.00727 AMU. Next, mass of neutron 1.00866 or 867 AMU. So electrons are negatively charged particles, protons are positively charged particles, while neutrons are neutral particles. So there will be no charge for neutron. Electron is indicated with E minus 1 0, protons plus 1 1, neutron 0 1. So these are subatomic particles or fundamental particles. That means properties of all the atoms will be decided by these three particles. Next one. Rutherford's nuclear model of atom. It will be also known as solar model or planetary model. So Rutherford has conducted all for a scattering experiment. All for a scattering experiment. So from this he has concluded most of the space in an atom is empty and electrons are revolving around this center with high speeds in definite orbits. So this part will be known as, if you consider atom like this is empty space. Most of the space in an atom is empty and this will be known as nucleus. Nucleus is center part. That means total mass and charge of atom is concentrated only at center. This center is known as nucleus. Remaining total space is empty and electrons are revolving around this positive charge in definite orbits with high velocities like this. Electrons are revolving like this. This is Rutherford's model. Completely, this is atom and the center portion is nucleus. So nucleus is very, very small and heavy. So total mass and total charge of atom is concentrated only in small region. Therefore nucleus is very, very small and heavy. Total mass is concentrated at that portion only. Therefore it is heavy. Next, what about size? So size of atom will be in angstrom units. That is, 1 angstrom unit equal to 10 power minus 10 meters. Size of nucleus will be in the order of Fermi units. Fermi units. That means 1 Fermi equal to 10 power minus 15 meters. So from this we can derive relation between volume of atom and volume of nucleus. Suppose volume of atom equal to 4 by 3 pi r cube. Here r is 10 power minus 10 cube. And this will be meter cube. Volume of nucleus 4 by 3 pi 10 power minus 15 cube meter cube. Therefore, volume of atom by volume of nucleus equal to, so here 10 power minus 30 by 10 power minus 45. That is 10 power 15. That means if volume of nucleus is 1, then volume of atomic will become 10 power 15 times. Simply, I will write here. Volume of atom will be 10 power 15 times than that of volume of nucleus. This is previous question. Remember this. Relation between volume of atom and volume of nucleus. If volume of nucleus is 1, then volume of atom will become 10 power 15. So this is about Rutherford's nuclear model of atom. Next. Wavelength of electromagnetic radiation. Simply EMR. So what are the characteristic properties of electromagnetic radiation? So all the types of electromagnetic radiations can travel with same speed, which is velocity of light. That is indicated with C. C equal to 3 into 10 power 8 meters per second or 3 into 10 power 10 centimeters per second. That is velocity of light or speed of light. Next here different relations will be there. See here relation between velocity of light and wavelength. C equal to nu lambda, where C is speed of light, nu frequency, lambda wavelength. Next, E equal to h nu, which is Planck's equation. We'll discuss later. Here E is energy, h is Planck's constant, nu is frequency. H into, from this we'll get nu value as C by lambda. Substitute here hc by lambda, which is hc into 1 by lambda. In place of 1 by lambda, we can write nu bar. Since nu bar is 1 by lambda. Reciprocal of wavelength is wave number, that is indicated with nu bar. Here see the terms. C, speed or velocity of light, nu frequency, lambda wavelength. Next E energy, h Planck's constant. Next 1 by lambda indicated with nu bar, which is wave number. Here we will get all the relations. So from this, see here, relation between energy and frequency. Relation 1, energy directly proportional to frequency. Relation 2, relation between energy and wavelength. Energy and wavelength inversely proportional to each other. Relation 3, E and nu bar, wave number, directly proportional. Next, one more important point. You know different types of electromagnetic radiations. First, cosmic rays. Next, gamma rays. Next, X-rays. Next, UV, visible, IR, microwaves. These are different types of electromagnetic radiations. Cosmic rays, gamma rays, X-rays, UV, visible, IR and microwaves. Remember these points. In this direction, energy, frequency and wave number increases. Next, in this direction, wavelength increases. Cosmic rays to microwaves, wavelength increases, and microwaves to cosmic rays, energy, frequency and wave number increases. From this you will get different orders. Questions will be like this. Arrange the following electromagnetic radiations in increasing order of their frequencies or increasing order of their wavelengths. Like that. For the type of questions, this will be very, very important. So this is about wave nature of electromagnetic radiation. Next topic, Planck's quantum theory or Planck's equation. So already we have discussed this point. Here one more important point is there. So according to Max Planck, radiation emitted or absorbed discontinuously. That means in the form of energy packets, which are known as quanta. Quanta means plural. So one energy packet is quantum. Number of energy packets means quanta. So energy of one quantum h nu, energy of n quanta, quanta means plural, n h nu. In case of light, you can write like this. If this theory is applicable to light, then we can write energy of, material particles are quanta and light particles are photons. Energy of one photon h nu, energy of n photons n h nu. Remember these two. In case of matter, we can use quantum or quanta. In case of light, we can take photon or photons. So here photon or photons are light particles. Quantum and quanta are material particles. Expression will be same. So E is energy of incident radiation or emitted radiation. Next, H is Planck's constant. Value is 6.625 or 6.626 into 10 power minus 34 joule into second. SI unit. 6.626 into 10 power minus 27 erg into second. C is S unit. Anyone we can take based on options. Next here, energy of radiation directly proportional to frequency. Already I have given these relations. Next, energy inversely proportional to wavelength and energy directly proportional to wave number. Remember this. Here small n represents number of quanta in case of matter or material particles, that is equal to number of photons in case of light. Small n represents number of quanta in case of matter, number of photons in case of light. So simple problems will be there on this topic. Next topic, photoelectric effect. It was successfully explained by Einstein. Here three types of energies will be there. Energy of instant radiation and energy absorbed by metal and energy supplied to electron as kinetic energy. In place of E, we can write h nu, energy of instant light, W h nu naught, plus in place of K you can write half mVe square. VE is velocity of ejected electron from metal surface. So nu is the frequency of instant light, nu naught threshold frequency. So here W can be written as h nu naught, which is threshold energy or work function. Threshold energy or work function, which can be defined as minimum amount of energy required for ejection of electrons from metal surface. So E is energy of instant light, W work function or threshold energy, the minimum amount of energy which is supplied to metal for the ejection of electrons, or energy taken by metal, absorbed by metal, kinetic energy. The remaining amount of energy supplied to electron in the form of kinetic energy. So nu is frequency of instant light, nu naught threshold frequency. So m is mass of electron, v is velocity of ejected electron. Next, from this we can write K equal to h into nu minus nu naught. K equal to h into nu minus nu naught. Nu is frequency of instant light, nu naught is threshold frequency. If nu greater than nu naught, photoelectric effect will be observed. Photoelectric effect will be observed. So this relation is very important for calculation of both work function, kinetic energy and velocity of ejected electron. Next, here 2 points are very important. Kinetic energy of ejected electron directly proportional to frequency. Next, number of photoelectrons. Number of photoelectrons means electrons ejecting from metal surface, directly proportional to intensity. Intensity of light. Intensity of instant light. Remember these 2 points. Kinetic energy is directly proportional to frequency. Number of photoelectrons directly proportional to intensity. Intensity can be taken as brightness. Brightness of light. As the brightness increases, number of photoelectrons emitted increases. As the frequency increases, kinetic energy of ejected electron increases. Next, kinetic energy is independent of intensity. Number of photoelectrons independent of frequency. Remember those 2 points also. Very, very important. Next, here work function can be taken as ionization energy or binding energy also. So W is h nu naught, work function, threshold energy, ionization energy and binding energy. Similar words. Next, for a given metal, work function is always constant. Work function is characteristic property of particular metal. Generally, alkali metals can show photoelectric effect. Alkali metals can show, that means first A group. Alkali metals can show photoelectric effect due to low ionization energy values. So due to low ionization energy values, they can lose electrons more easily. Therefore, photoelectrons will be ejected from metal surface. In first A group, more frequently used metals are potassium, rubidium and cesium. These can be used frequently. So these are important points about photoelectric effect. Next one. Bohr's model of hydrogen atom, or we can say hydrogen spectrum. So according to Bohr's model, electrons are revolving around the nucleus in definite circular paths, which are known as orbits. Next, orbits are designated with letters or numbers. Here I will write. If n equal to 1, which is first orbit, K shell. N equal to 2, L shell. N equal to 3, M shell. N equal to 4, N shell, like that. So orbits are designated with letters or numbers. Next, angular momentum of electron in definite orbit is mvr equal to nh by 2 pi. Here m is mass of electron, v velocity of electron in nth orbit or particular orbit, or radius of orbit, n orbit number, h Planck's constant, pi is also constant. Next, here we will be having different relations. Radius of nth orbit, 0.529 into n square by z angstrom units. First formula, radius of nth orbit. Radius of nth orbit depends on n value and z value. N is orbit number, z is atomic number. Similarly, energy of electron in nth orbit or energy of nth orbit. So minus 21.78 or 21.8 into 10 power minus 19 into z square by n square joules per atom. Minus 21.78. I am taking here 21.8 into 10 power minus 19. If it is 2.18, that becomes 10 power minus 18. Similarly, minus 13.6 into z square by n square electron volts per atom. Remember these relations. Next, minus 313.6 into z square by n square kilocalories per mole. And the last formula, minus 1312 into Z square by N square kilojoules per mole. So Z square by N square is constant. In all the formula, Z square by N square is constant. So Z is different for different elements. N is different for different orbits. So similarly, velocity of electron in nth orbit 2.188 into 10 power 8 into Z by N centimeters per second. So these values are very important. So radius of nth orbit 0.529 into n square by j. Energy of electron in nth orbit or energy of nth orbit minus 21.8 into 10 power minus 19 into z square by n square joules per atom. Minus 13.6 into z square by n square electron volts per atom. Next, minus 313.6 into z square by n square kilocalories per mole. So minus 1312 into z square by n square kilojoules per mole. So as the value of n increases, n means here principal quantum number or orbit number, radius of nth orbit increases. Next, energy of nth orbit also increases, but velocity of electron in nth orbit decreases. Remember this point. Radius directly proportional to n, energy directly proportional to n, but velocity of electron in nth orbit inversely proportional to n. So based on these formula, we can calculate radius, energy and velocity of electron in nth orbit. Next, when electron jumps from higher orbit to lower orbit, there will be emission of energy. We will get emission spectrum. When electron jumps from lower orbit to higher orbit, we will get absorption spectrum. So here E naught is energy of first orbit of hydrogen atom. In different units, joules per atom, electron volt per atom, kilocalories per mole, kilojoules per mole. Here remember these three relations: radius, energy, velocity and angular momentum of electron in particular orbit. Remember these. Next, which is most important topic, hydrogen spectrum. Hydrogen spectrum. So Rydberg equation. Rydberg equation for hydrogen atom. Nu bar equal to 1 by lambda equal to RH into 1 by N1 square minus 1 by N2 square. This is for hydrogen atom. RH is Rydberg constant for hydrogen. Similarly, Rydberg equation for hydrogen-like species. You know, hydrogen-like species means a species containing single electron. That means for He plus, Li2 plus, Be3 plus and so on. Nu bar equal to 1 by lambda equal to R into 1 by N1 square minus 1 by N2 square. So here R is RH into Z square. RH is Rydberg constant for hydrogen and Z is atomic number of hydrogen-like species. For helium, Z equal to 2, lithium Z equal to 3, beryllium Z equal to 4. Next, value of RH is, RH is Rydberg constant. This is equal to RH. 109677 centimeters inverse, which is constant. Next, N1 value is lower value, that means lower orbit, N2 higher orbit. N1 lower orbit, N2 higher orbit. So from this we can calculate wavelength of any spectral line. Wavelength or wave number also. Nu bar is wave number. So from wavelength we will get wave number. Wavelength, wave number, frequency, energy of any spectral line by using Rydberg equation. Next here, two more formulae are there. Number of spectral lines equal to n into n minus 1 by 2 when electron jumps from nth level to ground level. Very, very important. When electron jumps from nth level to ground level, the number of spectral lines emitted equal to n into n minus 1 by 2. Similarly, number of spectral lines equal to n into n plus 1 by 2, where n is n2 minus n1 when electron jumps from n2 level to n1 level, where n1 is not ground level. Two types of formula will be there. Number of spectral lines emitted when electron jumps from nth level to ground level, n into n minus 1 by 2. Number of spectral lines emitted when electron jumps from n2 level to n1 level, where n1 is not ground level, n into n plus 1 by 2, where n is n2 minus n1. So based on this, we can calculate wavelength, wave number, energy, frequency, number of lines, that means number of spectral lines emitted by using this formula. So this topic is very, very important for competitive exams. Remember here RH value 109677 centimeters inverse, which is constant, Rydberg constant for hydrogen. For hydrogen-like species, we should multiply RH with atomic number square. R equal to RH into Z square. Next topic, de Broglie's equation or concept of matter waves or dual nature of matter. Dual nature of matter or concept of matter waves. So a dual nature means both particle nature and wave nature. So any microscopic particle will be having particle nature as well as wave nature. Therefore, these two will be known as dual nature. Here, what is the meaning of matter waves? Matter waves means the waves associated with material particles. Here, material particles means, molecules, atoms and subatomic particles are material particles. That means by using de Broglie's wave equation, we can calculate wavelength of any material particle. Here, material particles are molecules, atoms, subatomic particles. Subatomic particles means, electrons, protons and neutrons. So he has given one relation, lambda equal to h by mv, that is equal to h by p. that is equal to h by, I will let all the equations once again, lambda equal to h by mv. mv can be written as p and h by root 2m into kinetic energy Ke and h by root 2m EV. Important topic for competitive exams. We'll get direct questions from this topic. Here lambda is wavelength of any material particle. H is Planck's constant value 6.625 into 10 power minus 34 joule into second. M is mass of material particle. V is velocity of material particle. mv is linear momentum. P equal to mv. Linear momentum. In place of mv, we can write P. Next, we know kinetic energy, relation between kinetic energy and momentum. K equal to P square by 2m. K equal to P square by 2m. Kinetic energy equal to momentum square by 2m. From this we can write P equal to root 2m into K, kinetic energy. Next, in place of kinetic energy, we can write charge into potential. E is charge of material particle, V potential. So from this we can calculate wavelength, next momentum, kinetic energy and potential also. Next, here relation between momentum and lambda, that is wavelength, is inversely proportional. Lambda inversely proportional to momentum. Similarly, inversely proportional to kinetic energy, inversely proportional to voltage. Capital V is voltage or potential, you can say. So what is the significance of de Broglie's wave equation is? So de Broglie's wave equation is applicable to microscopic bodies. It is applicable to microscopic bodies or material particles, we can say. Microscopic means mass will be less. It is not applicable to macroscopic bodies. That means for molecules, atoms, electrons, protons, neutrons, we can apply. Next, Heisenberg uncertainty principle. So this is also applicable to microscopic bodies. That means material particles for molecules, atoms and subatomic particles. So delta X, uncertainty in position. Uncertainty in position. Next, delta P, uncertainty in momentum. Next, delta V, uncertainty in velocity. Here position means position of microscopic particle or material particle. Momentum of material particle, velocity of material particle. So relation is given with delta X into delta P greater than or equal to H by 4 pi or delta X into delta V greater than or equal to H by 4 pi M. Now M is mass of material particle. So direct questions will be there on this topic. Simple topic only. Next here h by 4 pi is minimum value. Minimum value. Quantum mechanical model of atom or complete picture of atom. Here fundamental equation for quantum mechanics is Schrodinger's wave equation. So here dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into e minus v into psi equal to 0. So this is fundamental equation for quantum mechanics. Here I will write some important points. Here psi is wave function or amplitude of electron wave. So Schrodinger's wave equation represents three-dimensional motion of electron. Three-D motion of electron. Important point. So psi is wave function or amplitude of electron wave. It can be positive or negative. Next, psi square. Probability density or probability function. So psi square explains probability of finding electron around the nucleus. So based on psi square, we can explain probability of finding electron. Next, 4 pi r square dr into psi square represents radial probability distribution function. There are three functions. So first one, I will write here distribution function. Psi is wave function, psi square probability function. So psi is negative or sometimes it may be positive, but psi square is always positive. So this one also positive value. Psi may be positive or negative. Psi square is always positive. 4 pi r square dr into psi square radial probability distribution function always positive. So psi square explains probability of finding electron around the nucleus. Next, each psi value. So by solving Schrodinger's wave equation, we will get solutions for psi. So each psi value represents one atomic orbital. Each psi value is one atomic orbital. So therefore, psi value depends on three quantum numbers n, l and m. So psi n, l, m is one orbital. Very, very important. Where n is principal quantum number, l azimuthal quantum number, m magnetic quantum number. So psi value depends on three quantum numbers only, and that is independent of spin quantum number. So remember these values here. Psi, psi square, 4 pi r square dr into psi square. Next, quantum numbers. So we have four quantum numbers. Four quantum numbers. They are principal quantum number, azimuthal quantum number, I will write here. Principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. So these quantum numbers are just address for an electron. Address for an electron in an atom. That means by using these four quantum numbers, we can explain the position of electron in a particular atom. So in our principal quantum number was given by Niels Bohr. It is denoted with n. N can take values 1, 2, 3, 4 and so on. Next, number of orbitals in an orbit equal to n square. Maximum number of electrons will be equal to 2n square. Next, principal quantum number gives information about size and energy of orbit. Significance is very, very important. So values of n equal to 1, 2, 3, 4 and so on. Principal quantum number gives information about size and energy of orbit. Next, number of orbitals in an orbit equal to n square. Number of electrons in an orbit equal to 2n square. So here 2n square will be known as Bohr-Bury rule. Bohr-Bury rule. 2n square. Next, azimuthal quantum number denoted with L. L can take values 0 to n minus 1. The maximum value of L is n minus 1. That means azimuthal quantum number depends on principal quantum number. Number of subshells in an orbit equal to n. Number of subshells in an orbit equal to n. Next, azimuthal quantum number gives information about shapes of orbitals or shapes of subshells. Next, magnetic quantum number denoted with m. M values minus L to plus L including 0. M values minus L to plus L including 0. That means magnetic quantum number depends on azimuthal quantum number. Next, total number of m values 2L plus 1. Next, this gives information about orientations of orbitals in space. Next, number of electrons in a subshell equal to 2 into 2L plus 1 or 4L plus 2. Next, if L equal to 0, that represents S subshell or S orbital. Shape of S orbital or S subshell will be spherical. For that, M equal to 0. Next, L equal to 1, P subshell, dumbbell shape. 2 lobes will be there. M equal to minus 1, 0, plus 1. 3 values. Next, L equal to 2, D subshell, double dumbbell shape, 4 lobes. M equal to minus 2 to plus 2, 5 values. L equal to 3, F subshell, M equal to minus 3 to plus 3, 7 values. Each M value is one atomic orbital. Each M value equal to one orbital. Remember that point. Next, G1 effect and Stark effect. Based on magnetic quantum number, we can explain G1 effect and Stark effect. G1 effect is splitting of each spectral line into number of lines under the influence of magnetic field. Stark effect is splitting of spectral line into different number of lines under the influence of electric field. We can explain the splitting. Next, spin quantum number gives information about spin of electron about its own axis. So spin quantum number will be having two values, two possible values, plus half and minus half. If electron spin is clockwise, that is indicated with upward arrow. If it is anti-clockwise, downward arrow. So these 2 points are important. Upward arrow S equal to plus half, and here S equal to minus half. So plus half represents clockwise spin of electron about its own axis. Minus half represents spin of electron, anti-clockwise spin of electron about its own axis. Next, here orbital angular momentum. That means angular momentum of electron in an orbital. Root of L into L plus 1 into H by 2 pi. So in place of H by 2 pi, we can write H bar, which is constant. H by 2 pi is constant and represented with H bar. Next, spin angular momentum is root of S into S plus 1 into H by 2 pi. Here are three types of angular momentums. So angular momentum of electron in an orbit equal to nh by 2 pi. Angular momentum of electron in orbital equal root over L into L plus 1 into H by 2 pi. Spin angular momentum is root of S into S plus 1 into H by 2 pi. Remember these three. Next here, what is the meaning of node? So node is opposite to that of atomic orbital. So in atomic orbital, orbital is three-dimensional space around the nucleus where the probability of finding electron is maximum. That is orbital. Node is the point at which there is probability of finding electron is 0. Maximum probability indicates atomic orbital. So minimum probability indicates node. That is the difference between atomic orbital and node. At node, probability of finding electron is 0. At orbital, probability of finding electron is maximum. Next one. So number of radial nodes. Here I will add one more point. Number of nodes or radial nodes or spherical nodes or nodal regions, all will be the same. N minus L minus 1. Very, very important. Number of nodes, number of radial nodes, number of spherical nodes, number of nodal regions, all are similar. N minus L minus 1. N is principal quantum number, you know. L is azimuthal quantum number minus 1. Next, number of angular nodes or nodal planes equal to L. Then total number of nodes will be N minus 1. Total number of nodes equal to N minus 1. Remember these three. So nodal point is the point at which there is minimum probability of finding electron. Nodal plane means the plane at which probability of finding electron is minimum. Radial nodes n minus L minus 1, angular nodes L, total number of nodes n minus 1. If you take for px orbital, nodal plane will be yz. So electron density will be distributed only along x-axis. Therefore, on y-axis and z-axis, there will be no probability of finding electron. Therefore, yz plane becomes nodal plane. For py, xz is nodal plane. No density on x and y, x and z. For pz orbital, xy plane is nodal plane. So on pz, electron density will be along z-axis. There will be no density on xy plane. So for px, yz, for py, xz, pz, xy plane is nodal plane. Next, what are degenerate orbitals? Degenerate orbitals means orbitals which are having same amount of energy. Remember this point. Orbitals with the same amount of energy are degenerate orbitals. Next, three principles will be there for writing electronic configuration. So electronic configuration will be n L power x, where n is principal quantum number, which represents shell or orbit. Next, L, azimuthal quantum number, subshell or orbital. And X indicates number of electrons. This is general form of electronic configuration. N L power x. N gives information about orbit or shell. L gives information about subshell or orbital. X gives information about number of electrons present in that subshell or orbital. So first principle to write electronic configuration is Aufbau principle. It is based on Euler diagram. Euler diagram. So Euler diagram based on n plus L value. Energy of subshell or orbital equal to n plus L. So Aufbau principle based on Euler diagram based on n plus L value. So how to calculate energy of subshell or orbital means n plus L. As the n plus L value increases, energy increases. As the n plus L value decreases, energy also decreases. If two subshells are having same n plus L value, then electron enters into that subshell which is having lower n value. See here one second statement. In ground state of atoms, orbitals are filled with electrons in increasing order of their energies. That means first we have to add electrons to that subshell which is having lower energy. So electrons are arranged in different subshells in increasing order of their energies. So lower energy orbital will be filled first. In hydrogen atom, just take n value. Just take n value. For hydrogen atom, energy will be 1, less than 2, less than 3, less than 4, and so on. And so on. For remaining atoms, follow this order: 1s, 2s, 2p, 3s, 3p, 4s, 3d, and so on. Increasing order of energies of different subshells. So according to Aufbau principle, we have to fill electrons in different subshells or orbitals in increasing order of their energies. So how to calculate energy means n plus L value. If n plus L value increases, energy increases. So n plus L value decreases, energy decreases. That means energy directly proportional to n plus L value. If two subshells are having same n plus L value, then electron first enters into that subshell which has lower n value. Yeah, these points are important. So Aufbau principle related to energy of subshell. Okay, next one. Pauli's exclusion principle. So statement is no two electrons in an atom can have the same set of all the four quantum numbers. What is the meaning of that statement? See, second one. An atomic orbital can accommodate maximum of two electrons with opposite spins. Any orbital should contain two electrons, maximum of two electrons with opposite spins. That is the meaning. Okay, this is the orbital. Two electrons. Here it will be like this. The atomic orbital. Here first electron. Plus half spin quantum number. For this minus half. Any atomic orbital can accommodate maximum of two electrons with opposite spins. This arrangement of electrons in orbital. So Aufbau principle gives information about energies of orbitals or subshells. Pauli's principle gives information about the maximum capacity of atomic orbital. The maximum capacity of atomic orbital is 2. So one electron will be clockwise, other electron anti-clockwise or counterclockwise. So maximum capacity of any atomic orbital is 2 electrons. Next, Hund's rule. It explains about stability of configuration, electronic configuration. In degenerate orbitals, you know what are degenerate orbitals? So degenerate orbitals are orbitals with same amount of energy. So pairing of electrons takes place only when all orbitals are half filled. So this is applicable to P, D and F subshells. Hund's rule is applicable to P, D, F subshells. So you know P will be having 3 orbitals, Px, Py, Pz, and D 5 orbitals. Similarly F 7 orbitals. So while filling P subshell is a P subshell, you have 3 orbitals Px, Py, Pz. While filling Px, Py, Pz, first each orbital should get 1 electron. If you write like this, Px, Py, Pz, this will be wrong. This will be correct. So why? Because here there is exchange of energy. Stable due to exchange energy. Here what is exchange energy? So here 2 electrons will be exchanged out of 3. That means we can calculate number of exchange pairs. Number of exchange pairs equal to NC2. We have to select 2 out of N electrons. Here 3 unpaired electrons are there. 3 unpaired electrons. So therefore number of exchange pairs, remember this formula, number of exchange pairs equal to 3C2. That means 3 into 2 by 2. I will write here. Number of exchange pairs 3C2, which is equal to 3 into 2 by 2. That is 3 pairs. So due to 3 exchange pairs, there will be decrease of energy. If there is decrease of energy, stability will be increased. Stability of configuration. Energy. Inversely proportional to energy. So due to 3 exchange pairs, energy of P3 configuration, we'll say this is P3 configuration. P3 configuration will get more stability due to 3 exchange pairs. There is decrease of energy. So due to decrease of energy, stability will be increased. If you take D5 configuration, 5C2 will be there. 5C2. 5C2 configuration 5 into 4 by 2. 5 into 4 by 2 means 10 pairs will be there. So more is the number of exchange pairs, more will be the stability. Remember that point. Stability directly proportional to number of exchange pairs. In P3 configuration, we will be having 3 exchange pairs. In D5 configuration, we will get 5 into 4 by 2, 10 pairs. In F7 configuration, we will get 7C2, that means 7 into 6 by 2, 21 pairs. More is the number of exchange pairs, more will be decrease of energy and more will be the increase of stability. Remember that point. So based on Hund's rule, we can write electronic configuration of chromium and copper as follows. See here, chromium argon core 4s1 3d5, 4s1 half filled, 3d5 it is also half filled. So according to Hund's rule, half filled and completely filled orbitals are more stable. So completely filled orbitals are more stable due to spin pair. Spin paired. Spin will be cancelled. Next. In case of half filled configurations, due to exchange pairs, that configuration will be more stable. See here, in chromium 4s1 3d5. Here there will be exchange of unpaired electrons. Therefore, energy will be decreased. If there is decrease of energy, stability will be increased. Copper 4s1 3d10, 4s1 half filled and 3d10 completely filled. So Hund's rule explains the stability of half filled and completely filled orbitals. In case of completely filled orbitals, stability based on the pairing up. In case of half filled orbitals, based on exchange energy, we can explain stability. More is the number of exchange pairs, more will be the stability of that configuration. See here once again, Aufbau principle explains arrangement of electrons in different subshells or orbitals in increasing order of their energies. That is first principle. Next, Pauli's exclusion principle explains the maximum capacity of atomic orbital. An atomic orbital can accommodate a maximum of 2 electrons with opposite spins. Hund's rule explains stability of half-filled and completely filled configurations. Completely filled configurations are obviously more stable due to spin pair. Half-filled configurations are stable due to exchange energy. So based on these three principles, we can write electronic configuration of any element. So this is end of atomic structure. Complete synopsis. In next video, I will explain model questions from this chapter. Okay. Thank you.